Here are your solutions to 5-7. These are the letter problems. We'll start with letter A. Again, we have 2 points, 1, 3, and -2, 4. And from 1 to -2 is 3, and from 3 to 4 is 1. So we're going to use our hypotenuse or distance, either one, equals the square root of 3 squared plus 1 squared. And that gives us a distance or a hypotenuse of 3.16227, and we are going to round to the nearest tenth, so we're going to say that that is 3.2, and in this case we're going to say units. 3.2 units. Now the other thing is we actually should be plotting this point for a double check, so let's do that. 1. So from 0, on the x, we go over to 1, and then up to 3, we have a point right there, and -2, 4. So we go over to -2 and up to +4, we're right there. And now let's check, do we have legs of 1? We do, that's a 1. And the other leg we said over here was 3. There's our legs of 1 and 3, so we count this up, we have 1, 2, 3. We did use the correct lengths for our legs. All right, let's do problem B. In this case, we have Cromwell Field is located at 2.5, 3.5, and Dedeaux Field is at 1.5, 4.5 on the map, and each unit is 1/10 of a mile. About how far apart are the fields? So the first thing we can do is put our points here. We'll use this space here, 2.5, 3.5, and 1.5, and 4.5. Right here is where those numbers came from. So the length of this leg from 2.5 to 1.5 is a distance of 1, and 3.5 to 4.5 is also a distance of 1. So we have a pretty simple problem here. We have the square root of 1 squared plus 1 squared, which is, of course, the square root of 2. So the square root of 2 is 1.4142, but we're going to multiply that by this number here, so it's times 1/10, which means we're going to move the decimal place to the left. It's going to get smaller, so we have a distance of 0.14 miles, 14/100ths of a mile. Please press pause and do guided practice. Here are your solutions to 5-7 guided practice problems. Number 1 asks us to graph the ordered pairs 1, 5, and 3, 1, and then find the distance between the points, round to the nearest tenth if necessary. I'm going to do this 2 ways. I'm going to use my method, the 1, 5, the 3, 1, to find the legs, and then we're going to also double check it. So from 1 to 3 is a distance of 2, from 5 to 1 is a distance of 4, so those should be our 2 legs. So we plot the point 1, 5, start at the origin, go over to 1, and up 5, 1, 2, 3, 4, 5. We have a point right here. And then 3, 1. So on the x-axis, go over to 3, and then from there up to 1 on the y-axis. We have a point right here. If we then use these 2 legs, we should recognize that we have a leg here of 1, 2, 3, 4, a distance of 4, and here we have a distance of 2, so our legs are correct. So we can use the formula, the square root of 2 squared plus 4 squared. And the square root of 2 squared plus 4 squared would be 4 plus 16, or the square root of 20 if you go that way, and that ends up being 4.4721, and they want this to the nearest tenth, so our answer is going to be 4.5, and in this case we're going to write the word units because we don't have a specified unit, but it does have units because we are using a grid system here. So it should be 4.5 units. Problem number 2. On the park map, the ranger station is located at 2.5, 3.5. Let's put that right here, 2.5, 3.5. And the nature center is at 0.5 and 4. So it's 0.5 and 4. So from 1/2 up to 2.5, you should see is 2 units. And from 3.5 up to 4 is just 0.5 units. So we have our legs. We have the square root of 2 squared plus 0.5 squared. Put that in a calculator, and we will be taking the square root of, this would be the square root of 4.25 if you're doing it that way, or just plugging it right into the calculator. You're going to get 2.06155, etc. But now they're telling you that each unit on the map is 0.5, or 5/10 of a mile, a half a mile. So we're going to multiply that times 0.5. And once we do that, we get 1.03077. And we're going to round that to the nearest tenth. So for problem number 2, we would have just this here, 1.0 miles. Problem number 3, building on the essential question. How can you use the Pythagorean theorem to find the distance between 2 points on the coordinate plane? Well, basically the answer to this question is you can do one of two things. You can either plot those points and then count the distance of the legs, or you can do it the way that I did it earlier, where we can use the distance formula, so you find out how far x1 and x2 are from each other. So in other words, if we have 3 and 5 for our points, and -8 and -3 for our points, we would say how far apart are these? One leg is 11. How far apart are these? The other leg is 8. Because from 5 to 0 is 5, and then another negative to -3 be 3 more, that'd be 8. From 3 to 0 is 3, and then 8 more left of that would be 11. So this is kind of using the distance formula, but in a way that I think kids understand it better. But you could also do it this way here, where you just plot the points, and then you count the actual distance of the leg here and here. Please do independent practice.